Has anyone started to sign up for classes in spring?
I started to today, but I had to comply.
I heard that one section of the 360s was already done.
As of last night.
As of last night?
As of the day it started registering, it was closed.
So is that the next? Is that the
Yes,
next from here?
it is.
Yeah. But there are two sections. But there are two sections. One section is full on the first day it was open. Yeah, go ahead.
The other section is kind of weird. It has the lecture on like Mondays and Wednesdays, and then the lab on Tuesdays and Thursdays. And
Okay.
like it starts at like 10:30 on Mondays and Wednesdays, and it starts at like 5:20 on Tuesdays and Thursdays. It's really weird, and I don't like it.
I think it's a hybrid too. So a part of it is actually online. We'll take a look at that one too when we have time. So I will stop by and actually take a look. Okay, so getting back to this homework assignment. Now that the recorder is on, I'm just going to double check that I am recording. Yep, it is. Because sometimes I turn on the recorder, but there's no sound because I forgot to switch the sound source to the microphone. All right, so this is our new homework assignment. It's called Traverse. It has one parameter that's passed by reference, but when you look at how A is used in this particular subroutine, it is kind of weird because A is used as an array, okay? Because otherwise we would not be able to do a bar A bar or use the square bracket symbol with A. So the next question is, how are we going to pass an array by reference to a subroutine? That's going to be a topic for today's lecture, okay? I'm not going to talk about passing an array by value, even though it is supported in some programming languages. C and C++ does not support that. Okay, so I'm not going to talk about it so that you guys won't even be able to confuse it because I'm not going to talk about passing by value with arrays. But this is the go ahead.
Do you not have this accessible right now?
Say again?
Is the link live?
Yeah, it is. It should be.
I don't think so.
I opened it.
You did?
Yeah.
Uh-oh. Moodle is giving some people preferential treatment. All without any doing from my side. Oh, this is spooky. Okay. Maybe you just didn't hit the link, it's this file that is a link. Okay. So this is what we'll talk about today, is how do we pass an array by reference to a subroutine, okay? So are there any questions yet, about this homework assignment? It will take a little bit longer. This one is a little bit longer. It has recursion and all the other stuff, but it has a loop inside the recursive subroutine too, so it's going to be a little bit longer. Yep.
Are we going to do the test on Thursday?
We'll go over it today. Yeah, I would just spend the first 15 minutes or so to talk about this, and then we'll go back to the test. All right. So let's go ahead and, I'm not going to do the homework assignment for you, but what I will do is I'm going to give you a sample program. So I will go ahead.
No, sorry.
Okay.
Talk
So,
about football.
Okay, so I'll give you a task subroutine here, okay, which has some of the features of the homework assignment, but not all. Okay, so I'm gonna say this is going to compute the sum of all the elements in an array. That's what it's gonna do. So I will say pass by reference A is an array. Pass by value I, which is an index. So the first condition is if I is less than bar A bar, then do the following. What I'm going to do here is to say return A bracket I plus invoke sum, pass A along to the next invocation, but pass I plus 1 along to the next I. So this is what I'll do to compute the sum. In a way, this is actually a little bit more complicated or trickier than the homework assignment, but in a way it is also simpler because it is shorter than the other one. So when I trace the algorithm, you will find out, you will realize what I mean by that when I said, this is a little bit trickier, but it's longer. Okay. So here we have defined some main, and I need to have a local variable A first. I might be missing that in, nope, I did not. It's in here. So local A is an array of 7 elements, so I will use the same approach here. Instead of 7 elements, I'm going to make this a little bit shorter. So I would say A is an array of, let's say, 3 elements. Okay. Then we can go ahead and initialize elements in A. A bracket 0 gets a value of 5, A bracket 1 gets a value of -2, A bracket 2 gets a value of, it doesn't matter, it's just an example, 7. Okay. Then I'll go ahead and say print, invoke, use parentheses, invoke sum, and A is going to be used, I'm going to use a different name, changing my mind here. So just so that I can easily differentiate here which one is which one. It doesn't really change the homework assignment. The homework assignment can keep using A, it doesn't really matter. But in this case, I just want to be more clear. So I'm going to say use B as my local variable. Invoke sum, B specifies A, 0 specifies I, and define sub, invoke main. Alright, so this is what we'll do right now, is to trace this algorithm and find out what it's going to do. By the name of the subroutine, I think we kind of know what it's going to do, okay? But the question is, what is the mechanism? How do we pass an array by reference? And then once we pass it by reference, how do we make use of it? And what does this algorithm actually do? Those are the questions that I want to answer in the next 10 minutes or so when I trace through this particular algorithm. So let's open up a new window for the trace itself. All right, so we do have, we do need one column for comments because we have conditions. We have one condition to evaluate on line 4, even though we'll be visiting line 4 quite a few times. We have line number. The precondition has nothing to say because we do not have any global variables in this case. If you look at all the names used in both subroutines, in subroutine main, the only name that I refer to is B, but B is a local variable, so that's accounted for. In the subroutine sum, I refer to the name A and also the name I. One is passed by reference as a parameter, the other one is passed by value as a parameter. So once again, they are accounted for. So we do not have any global variables in this particular algorithm, which is good because we don't want global variables when we can avoid them. All right, so the precondition has nothing to say because we have no global variables. And then we start execution on line 15, which is the first line outside of the definition of a subroutine. And line 15 doesn't have much to do except to remember the return line number, which is post, because there are no additional lines after line 15. And then it has to allocate for the local variables and parameters in main. We don't have any parameters in main, but we do have one local variable, B. Okay. And in this case, I make it very clear that B is an array and has 3 elements. So what we'll do is we'll do the allocation on the fly here, except we're allocating 3 columns because we are allocating for an entire array. So B is going to occupy column D, column E, as well as column F. Now, because B as an array is a local variable, that means every single element in the array is going to have an uninitialized value. So this is how we allocate an array as a local variable. Okay, it's not much different from what we already have done with arrays. It's just that now we allocate the entire array on the fly when we are in a particular subroutine. Are there any questions about this mechanism? Yep.
The question gave us the value of the numbers. Why would question mark?
Because the value of any local variable is always unknown to begin with. So it doesn't matter whether it is a single value or an array or elements in an array, because they are always uninitialized. And therefore we do not know their initial value.
Until we get to that point.
Until we get to the point where we initialize, right? So until we get to line 10, 11, and 12, the elements of B remain uninitialized, and that's why they are unknown, and that's why they have a question mark. Okay? Did I answer your question? Okay. All right. So once this part is done, we have done all the allocations, we can continue execution in main starting on line 10. Lines 10, 11, and 12 are fairly straightforward. They're all just assignment statements. So as assignment statements, we're just changing those particular columns to 5, -2, and 7, respectively. Are there any questions about these 3 lines, the execution of lines 10, 11, and 12? Okay, it's pretty standard stuff. Nothing too fancy here. Line 13 is the trick. Okay, what are we going to do with line 13? Because it has a combination of stuff that we already know and understand have gone over in class, as well as one concept that we have not gone over in class. So let's go ahead and look at line 13 and see what we have to do. Okay, since we don't need comments right away, I'm going to shift the columns a little bit so we can focus more on the other columns. On line 13, when we invoke sum, we know that we have to come back onto line 13 to finish the rest of the line, which is to print out that value to either the screen, a piece of paper, or something. So the print action is something that we have to do after we come back from the subroutine sum. Okay, well that's good, because once we understand that, we know that we cannot use return line number, because we cannot just say, oh, we're going to go back to line 13, or we are going to line 14, because we're going back to line 13 to continue to finish up what we have left off the first time we get to line 13. So we have to use return info, which means we have to indicate the line number that we are going back to. But in addition to that, we also have to say what else do we have to do on that line after replacing the invocation itself with a single question mark. So this part is nothing new. I mean, we talked about this before the break. And let's deal with the easy parameter first. Okay, the easy parameter is parameter I, which is passed by value, and it is a single value. Okay, it's a constant. It's just a 0. So that's an easy one to deal with, because I as a by value parameter simply starts with a value of 0. Okay, that's done. Easy. Okay, now we look at the one that is a little bit more tricky, because we have A as a pass by reference parameter. We know what passing by reference means. We want the subroutine to be able to get to the original item. That's the whole purpose of passing by reference, is for the subroutine to have access to the original item. So in the case of a book, okay, remember the analogy of proofreading? Okay, in the case of a book, the reference number is a reference, because the reference number, even though it's only a little number, code, I can use that code to go to the library to find the original book. Okay, so at this point, what is A? A is passed by reference, so it is supposed to be an alias of whatever I use to specify that particular parameter. On line 13, I use local variable B to specify A. So that means A should be now an alias of local variable B. Local variable B does not occupy a single column. It occupies columns D, E, and F. So A is now an alias of those columns. It is not an alias of a single column, but it is an alias of multiple columns in this case. Or at least conceptually, this is how we look at it. Okay. In terms of C++, that's not exactly how it is represented, but in this class, we'll pretend that A is an alias of all 3 columns. Okay. C++ actually has a much more primitive way of looking at arrays and how to pass it by reference. But in this class, we'll use a view that is more consistent with more advanced, more modern programming languages, which is passing the entire, it's a reference to all 3 columns. Okay, are we still doing okay so far at this point? That when we pass an array by reference, we are simply making the parameter a reference to all the columns that we want to refer to, not a single one. Yep.
Would you mind shifting the active window over to the right so I can see the rest of line 13?
Shifting
The active window to the right so I can see the end of line 13.
you mean like
The
this?
side of the window, so we can see the.
It's just I and parentheses.
Oh, just I.
code.
So,
Bring the other window.
yeah, okay, thank you.
That's the background window.
Or the pseudocode. Okay. Well, yeah, this is going to be a little bit troublesome because the screen is only so big. I cannot easily display both at the same time.
Yeah, no, I just didn't catch all of 13 when you were ready.
Oh, okay.
You can move back.
Okay. All right. So line 13 is going to has already set up all the columns. So now we can go in and see what the subroutine itself is going to do. Starting on line 4, because line 2 and 3 we don't trace, they are simply saying that A is passed by reference and I is passed by value. So on line 4, we have to evaluate this condition, which is I is less than bar A bar. Okay, so now we have a little bit of a problem, because what exactly is bar A bar? Well, we have to refer to the names, right? So A is column H. Column H is an alias of column D to column F. So we are effectively asking how many elements do we have in column D to column F? Oh, we have 3 elements. So bar A bar now resolves to 3. I is 0. 0 is less than 3 is true. So we have to move on to line 5. So now we move on to line 5. Oops. And line 5 looks like this. Okay, so it looks kind of nasty. At the same time, it's also something that we have seen before. The first part is return A bracket I plus, and then we have the invocation of a subroutine. In this case, you kind of have 2 ways to approach this. I approach it in a particular way, but you can choose the other way as well in this particular case. In this case, you can say, oh, okay, I can right away I can resolve what is A bracket I, because I know what A is, I know what I is, so I can actually refer to that element. You can actually do it now. The other way to look at this is to say, well, I'm not quite ready to do that yet, because I want to resolve the invocation of sum first. Okay, when I come back, then I'll go ahead and evaluate what is A bracket I. Both ways are okay. I believe the C++ programming language specification does not say anything about which way is correct. Okay. In this case, it's not going to change the result. One way or another, you will get the same result anyway. But there are cases where you can potentially get a different result, because if I pass I by reference to the subroutine, in this case I pass it by value, which means it doesn't do anything to I. But if I pass I by reference to the subroutine, when the subroutine returns, the value of I can potentially be changed. Which also means if I defer the evaluation of A bracket I until the invocation is done, I can be referring to a different element at that time. Which may or may not be what the algorithm wants to do, but the programming language C++ does not enforce a particular order in cases like this. So your best option is to avoid writing programs in this particular way, where the ordering of the evaluation can change the result. Okay. So in this case, I'm just going to defer the evaluation completely until the invocation is done. Okay. So this is line 5 on row 12 of the spreadsheet. So I'm gonna, it's gonna get a little bit harder to read because I have to kind of spread things out a little bit. So once again, it has to use a return info, because I got several things to do when I get back onto line 5. So I have to say, okay, we have to get back onto line 5 after this invocation of sum, but what else do we have to do on line 5? The return action is not done. Resolving A bracket I is not done. The addition is not done. So all of these things are things that I have to do when I get back onto line 5. Are we doing okay so far with the setup of return info when we execute line 5 the first time? Okay. Now, since we're invoking sum, we also have to remember to pass along the parameters. We have parameter A as well as parameter I. Parameter I is the easy one, because it is I plus 1, the current I that I have at this point, which has a value of 0. 0 plus 1 is 1, and I use that 1 to specify the new parameter I. So column L, which is the column of the new parameter I, has a value of 1. That part is fairly easy. We have done it before with our programs that we have seen before. Parameter A is also something that we have seen before because we have a parameter A that is passed by reference to me, and I'm now trying to pass it by reference to somebody else. Does anyone remember which way we should do this? Are we just passing the reference itself along, or are we passing a reference to the reference?
To the reference.
No, we just press reference. We don't need a copy of a copy.
Yep, we just make a copy of the reference and just pass it along. Okay. So remember the analogy? I was the proofreader, and I have somebody who is actually I'm subcontracting the spell check to somebody else. Do you guys remember that? So instead of making a reference of my little slip of paper that has the reference number to the book, I just make a photocopy of the call number of the book and then pass it along to the spell checker. Because all the spell checker wants is a way to find the book, right? So why make the spell checker go through one more step to find my slip of paper that has the actual call number? So we just pass the reference itself along in this case, which means whatever A is, which is also known as column D to column F, we just copy it over here. Also known as column D to column F. That's all we do to set up the new parameter A. Okay? If there's one thing you want to remember, it is one. This is what we need to remember. We do not pass the reference of a reference in this class. In C in general, that's also something that you do not want to do until you encounter the concept of a pointer to a pointer. I think they might be talking about that right about now, you know, in the last 2 weeks of the entire semester. So don't worry about the reference to a reference until the very end of cisp300. All right. So now that we have all the columns, you know, set up, let's go ahead and continue our execution of the code here. And it's getting a little bit hard to read because, you know, one screen is just taking up too much space. I'm going to zoom out on this screen here, so I have a little bit more space on this one, and zoom out just a little bit too, just so that we can fit more stuff on screen. All right. Now that all these columns are set up, I can continue execution in the subroutine that I'm invoking, which is starting on line 4. Now we get back onto line 4, and we have to look at it. Okay, it's time to split the screen a little bit. I'm going to split it like this. So now we continue execution on line 4, and line 4 is comparing I to bar A bar again. Okay, so we kind of know what we need to do at this point, because we need to go to the comments column and say I is less than bar A bar. Oh, I forgot about the other one. It is true. So in both cases, they are true. It's true, like that. And then go to line 5 again, because when the condition is true, we go to the then branch. In this case, the then branch is line 5 again. When we get to line 5, I think most people know that, okay, we just need to copy and paste this and change a little bit of the values. And the only one that needs any change is column O in this case. It goes from 1 to 2 because we keep adding 1 to parameter I based on the previous one. Right? Okay. And after that, I continue execution in the subroutine that we're invoking, which is sum. It starts on line 4 again, and then we reevaluate I is less than bar A bar. It is true for the very last time, because at this point I has a value of 2, bar A bar is 3. So we go to line 5 again, and we say, okay, copy and paste it, and change the value of parameter I, this time to 3. And we'll fix the width of the columns. And now we continue execution in the subroutine that we're invoking. I is less than bar A bar is finally false. And I just found that I have a mistake in the algorithm. But this is a good one. Okay. Even though it was not intentional, it does demonstrate one thing. Okay. You know what it is, right?
No, I didn't.
You don't know? Okay. Okay. My algorithm has one mistake, has one omission. And I'll go ahead and tell you what when we trace it, you will find out what the omission is. Okay. Okay, so this is the omission. The omission doesn't seem obvious until we get to the end of the subroutine. Okay, so the condition is false on line 4. That means we skip the then branch. I don't have an else branch, so we go straight to line 7. Is that right? Okay, that's the behavior of a conditional statement that has no else. Okay, we don't have an alternative branch to execute when the condition is false. So we get to line 7. At the end of a subroutine, well, we kind of know what to do, right? We look up the rightmost active return line number or return info in this case and say, okay, that's where we go back to continue execution. Okay, no problem, we can do that. So we look up column P and say, okay, we are supposed to go back to line 5, and that's what we have to do back onto line 5. Make a note of that, okay? We don't even notice a problem at this point. And then we say we have no use of these 3 columns anymore. We go ahead and deallocate all 3 columns. Okay, strike through, no problem. We get rid of all 3 columns. And now we continue execution on line 5. Now we have a problem, don't we? What is the problem?
You can't access AI because it's A.
Oh, we can access A bracket I. That's not the problem. A is still okay. I is still okay because at this point, my columns are back to column N and column O. So I still know what A is. A is an alias to column D to column F, and I has a value of 2. That's not a problem. What about the other side of the addition? It still has a question mark, doesn't it? Because I did not have a chance to execute a return statement in sum, the very last invocation didn't have a chance to execute a return statement. And as a result, I did not have a chance to change the question mark to a particular value. And now it is still a question mark, which means it is unknown. Is that making any sense? Okay. So the next question is knowing that this algorithm has a problem, because by the time we get back onto line 5 on row 22 of this particular trace, I'm going to fix the algorithm later. But at this point, when we are on line 22, row 22 of the trace, we are on line 5, we're executing A bracket I plus question mark. A bracket I is not a problem. Okay? We know that A bracket I is referring to really just B bracket 2. Right, because I equals 2, and A is a reference to the entire array B. So we don't have a problem. It has a value of 7. But what is 7 plus question mark?
Question mark.
It's a question mark. It's another question mark, right? Okay, so if you follow that reasoning all the way back to line 13, because everything has to go back to line 13, we'll be printing some unknown value. Okay, but when this program actually executes, it doesn't do anything like, oh, I'm going to print a question mark on the screen because I don't know what it is. It's going to print a number. But that number can change every single time. It can change from one machine to the next. It can change from one operating system to the next. It's just going to be a number that it pulls out of nowhere. Well, it's not exactly nowhere, but it is, a number that you cannot predict. Am I making the point? Okay. And this is a fairly common mistake. Okay, it's actually a fairly common mistake that in certain branches inside the subroutine, we forget to specify a return value. Okay, the compiler actually has the ability to check this and say, hey, this subroutine may have a particular branch in which you won't specify the return value by the time you exit the subroutine. Okay, a C compiler can do it. But you have to tell the compiler to nag and to be very detail-oriented in order to turn on that feature. Okay, I don't know who's going to teach C++, in your case. So I'm not sure whether they will, ask you to turn on everything, all the possible checking that the compiler can do. But if you don't turn on those features, the program will compile without a problem. But when it runs, it's going to give you some random number. Okay, instead of the actual value, which is the sum of all the values in the array. Okay, so now that we know what there's a problem, it is time to fix it. Okay, so what I'll do is I'm going to fix it with, I'll save it first and call this, oops, okay. and then we'll save it again as a different name. So this time we'll just call it fixed. Okay, how do we fix this? Well, to fix this means we have to guarantee that the subroutine will execute at least one return statement when we execute it. Okay, that's an easy one here. What we can do is to say, well, let's make an else branch out of this. Okay, and since else itself is not trace, I will not give it a line number. But the branch here, what it does in the branch does have a value, does have a it needs a line number. So we'll just call this line 5.5. Okay. Because I don't want to change the rest of the program. Otherwise, I have to redo the entire trace. I don't want to do that. So I'm just going to call line what should be line 7, line 5.5, and then the rest of the lines will stay the same. Okay. Okay. So now we can go back to the trace and fix it. Okay. Because when we get back to the trace, we have to backtrack all the way to here and say, okay, we are now fixing it so that after line 4 of the last invocation, we're going to do something a little bit different this time. So we'll go ahead and delete the selected rows. And this time, instead of going to line 7 right away, we do have an else branch here. So we will continue execution on line 5.5. Are we doing okay so far? Okay. So I just fix the program. And what is that going to do in terms of the columns? Let me make it look like this. Okay. So we are now on line 5.5, which is just return a value of 0. What does a return statement do when we execute it?
Substitute 0 with question mark.
Exactly. We change the question mark to the value that we are returning, but it has to be a specific value. Okay. So in this case, we have a very specific value of 0. So we copy and paste the return info cell, change the question mark to the value that we are returning on line 5.5, which is just 0, and we're done. We're not doing any additional thing. We're not evaluating what is a bracket I. We are not doing the addition. We are just changing the question mark to the value that we are returning. We're done with line 5.5. Then we can now continue on to line 7. Line 7 is going to do exactly what we did before. We'll copy and paste the entire return info cell to the line number column. So this way we know exactly what we have to do when we get back onto line 5. And then we'll say, okay, these 3 columns are no longer in use. Let's go ahead and deallocate all 3 columns. And now we're back to the other portion. Yep, go ahead.
So I just thought that we would get that question mark from the invocation. It seems like invoking some A to A, whatever, that seems useless, like we're not getting a value out of that.
Well, not the last invocation, because in the last invocation, I is out of bound already, and I'll just say, okay, this is not even a part of the array. I cannot do summation on this part because it's not even a part of an array. So naturally, the summation is 0. Okay, the sum of that portion of the array is 0. But now that we are getting back to line 5, I has a value of 2. Now we have to evaluate what is a bracket I plus 0. A is a reference to column D to column F, and if you still remember, the way I initialize B bracket 2 is 7. So now this becomes 7 plus 0, which is just 7 itself. In other words, we are now executing the statement return 7. So what do we do when we execute a return statement? We just answered that question maybe 2 minutes, 3 minutes ago. We copy and paste the return info cell, change the question mark to the value that we're returning. So in this case, which cell are we talking about? Or which column are we talking about?
I is 2, A bracket 2, yes.
Say again?
7.
Well, okay, but when we execute a return statement, we have to change a question mark, right? That's the whole purpose of the return statement. So which question mark of which return info cell are we changing?
M, right?
Column M, okay, and in this case, it's M16 is actually the cell that we are talking about. We copy and paste it, and then we change the question mark to the value that we are returning. Okay, now this looks awfully confusing because we are executing a return statement, and at the same time we are modifying a return info cell that has a return in it. But don't let it confuse you, because we are executing whatever is in column B, and its effect is copying and pasting the return info cell and changing the question mark to the value that we are returning. Okay, so that's why you have to, if you just look at this, it looks confusing, but if you think about which column has what purpose, then it should not be as confusing. We're done with line 5. We now move on to line 7. Line 7 is going to do pretty much the same thing as last time. We make a note of where we're going back to using the return info cell. Okay, so we copy and paste the entire return info cell. Then we have no use of these 3 columns anymore, and then we just deallocate all 3 columns. Like so. And now we are continue execution on line 5. But the columns are now shifted back to columns J, K, and L. And even though I'm executing line 5 again, the right-hand side of the addition is no longer 0. Now it is 7. And I has a value of 1. A is still a reference to columns D to column F, which is my array B in main. Are we still doing okay so far at this point? Yep, go ahead.
Just to like recap the return statement. So you copy the value you get from return info, and then you replace the question mark with that value.
With the value that you're returning, right? Okay, so let's go ahead and do this. That's why I choose an array that has 3 elements, so we can do this a few times. So this way, you know. Okay, so this is what we do. We are currently on line 5. How do we know we are on line 5? Because this is my line number column. Okay, so that's why I know I'm on line 5, and this is the rest of the statement on line 5 that I have to, you know, perform, because the invocation is done. It is resolved to a single value of 7 already. In other words, I am now executing, should not have double clicked it. I'm now executing return A bracket I plus 7. That's what I'm executing at this point. So my first thing to do is to say, okay, but what is A bracket I? A is a reference to columns D to column F, and I has a value of 1. So effectively, we are referring to B bracket 1, because A is referring back to the entire array B, and I has a value of 1. So we are referring to the value of B bracket 1, which has a value of -2. So now we are saying, oh, okay, so the left-hand side of the addition is -2, the right-hand side is 7, -2 plus 7 is 5. We are executing return 5. Are we still doing okay so far? Okay. We are returning 5 because we are executing this statement here. Okay, let me make this a little bit bigger so we can see. There we go. Okay, so basically we are executing this statement. This statement is returning the sum of those 2 numbers, right? The right-hand side is already resolved to a single value of 7, so that one I don't have to worry about. So I have to find out, okay, what exactly is A bracket I? So we have to look up A first. A is also known as column D to column F. We look up, you know, what is column D to column F. Column D to column F is an array, and we want to access element 1, which is column E. It has a value of -2. Okay. So at that point, I know that this is basically -2. This is 7. -2 plus 7 is 5. So effectively, the entire thing, if I look at the entire value that we are returning, it is 5. We are returning a value of 5. Okay. This is what we are executing. We are executing return 5. When we execute a return statement, we take whatever the rightmost return info cell has. In this case, it is this guy here. We just copy and paste the entire thing. And then we change the question mark to the value that we are returning. Remind me again, what value are we returning? 5. Yep. So that's what we do. Okay. The confusing part is the return info cell looks like the statement that we're executing. That is why it is confusing. But column B serves an entirely different purpose from column J. Column J is a breadcrumb that we left behind so that we know where to go back to when the subroutine is all done. Column B is where we stand at this point. Are we doing okay so far? Okay. So we are basically modifying the breadcrumb that we left behind a little bit earlier to basically say, okay, tweak it a little bit. Okay, I'm putting peanut butter on that breadcrumb. But that breadcrumb is still back there. Okay, I'm standing right here. So after that, we continue execution on line 7 because that's all line 5 is going to do, is to copy, paste, and then change the question mark. Now we move on to line 7. Line 7 is the end of a subroutine, and as a result, it has one thing to do. It has two things to do. One is to look up the rightmost return info cell, which turns out to be this one. Copy and paste it, basically make a note of where are we supposed to continue execution when this invocation of sum is done. And then once we have done that, we have no use of those 3 columns anymore, and then we mark those as deallocated at this point. And then we continue execution based on the breadcrumb that we left behind a little bit earlier. Are we still doing okay so far? Except this breadcrumb is no longer plain. Now it has peanut butter on it. Okay? But this instruction, okay, the instruction on the breadcrumb itself is to say retrieve the other breadcrumb that is still in my trail earlier and change it. Okay, because now we're talking about this one here. So we first have to evaluate and say, okay, 5 is 5, we're good with that. Next is, what is A bracket I? I at this point has a value of 0. A is still a reference to columns D to column F, so we are effectively referring to B bracket 0 at this point, which has a value of 5. Are we doing okay so far with that? Okay, so the highlighted portion on the screen, A bracket I, resolves to a single value of 5. The other side of addition is 5 as well. So now we have 5 plus 5. 5 plus 5 is 10. And we are executing the statement as return 10. Return a value of 10. Okay? Which is equivalent to find the previous breadcrumb and put jam on it. Okay? Yeah, it's always nice to talk about food when it's about time to have lunch.
Roll sheet?
Roll sheet? No, I don't have a roll sheet. I can't drop you guys anymore. Neither can you. Yep.
What would this be useful for? What would be,
Okay.
practical?
Well, let's deal with this one first, and then I'll answer your question. Okay. So now we go back to, this is the return 10, right? Because the value of this expression is 10. So now we take whatever we have in the return info cell, copy and paste it, and say, okay, let's put strawberry jam over it. So in this case, strawberry jam is 10. Okay. But it's not time to consume that breadcrumb yet. Okay, we're just putting something on it. After the return statement, we continue execution on line 7 again. Line 7 is the end of a subroutine. We once again make a note and say this is where we're going back to because that's where we left behind as a breadcrumb. And then we say we can now deallocate all of this stuff here because they're no longer useful. And now we are back to line 13. Except that when we are back to line 13, the value that we're supposed to print is now fully resolved to a single value of 10. So what is left to do on line 13 is just to print it out. Okay? So I'm just going to print it out either to the screen, to a piece of paper, whatever. But I'm just printing the value of 10. I'm done with line 13. Move on to line 14. Line 14 is easier because it just looks up the return line number in this case. We are now back to this point. So we are looking up the return line number and make a note and say, okay, we have to continue execution at post But as soon as we are done with that, we say, okay, these four columns are no longer in use. Oops. So we copy and paste here, use strikeout to indicate those 4 columns are no longer in use, and we continue execution at post, then we're all done. Yep.
When you deallocate an array like that, as far as just making a notation, just having to be alone is enough. You don't need to.
Yeah. If you want to be specific, you can put in the square bracket stuff here too and strike them out too. Yep. Okay. So do we have any questions? I will get back to your question. I remember your question. Okay. Yep.
So this is just a really long way to add up everything. Right?
Yes, it is.
I can see that. If you're writing a spreadsheet program, I can see how adding them all up would be very useful.
Okay, so I can, but I have a, I can also address, what you just said. It's just a long way to add up numbers, but I can easily modify this, algorithm to add up the sizes of all the files within a folder, including all of its subfolders.
Yes, if you're getting info on a file, that'd be great.
Yep. Go ahead.
I was going to say something similar to that. Once you start having like categories of stuff that you have to deal with and put into an array, you can do lots of things to those elements within those arrays to deal with them.
In this class, we don't have the exposure to really structured things. Okay, like a directory that's structured, right? Because you have a folder that can have a subfolder, and the subfolder can in return contain subfolder and so on. So it is a structure that has no set limits. In other words, practically there's no particular limit of how deep you can embed subfolders into. Even though there is a theoretical limit, okay, but as far as we are concerned, you can have 5 levels deep, 10 levels deep. It's flexible. So that's why you cannot have an easy algorithm to deal with structures like that, because it can go deep, it can be very shallow. It depends on what you use the folders for. Now, getting back to your question, okay, that kind of lends itself to to answering your question. Is there are many things are inherently recursive, which means the larger problem that you have to solve is inherently just one step on top of a smaller problem that is expressed in exactly the same way. Okay. So let me just look at this one here, because this one looks like, hey, there's no point in doing it like this. Okay, for those of you, okay, let me just kind of express it in this way first. So what I really want to do is to say, a bracket 0 plus a bracket 1 plus a bracket 2. I'm just trying to add up all the values of the entire array. That's what I'm trying to compute, right? Okay. For those of you who know summation, the summation symbol, okay, it's how many people know about the uppercase sigma symbol? Okay, I think it's a fairly useful symbol. Okay, so I goes from 0 to 2, and I just want to add up all the AIs. Okay, so in this case, I'm using the mathematical notation, so just using a subscript to indicate basically the indexing operation. Okay, but this, in return, all these pens are sort of out of ink. Okay. But I can express this as a bracket 0 plus the summation of I going from 1 to 2 a subscript I. That's basically what it is. The big summation, I solve it by saying, oh, okay, I know what I am. I'll just go ahead and ask somebody else to figure out the summation of the other items. Okay? And that's recursive. This is quote unquote a recursive definition. But if you take this one step further, what you can say is, if I want to find out the summation of I going from some, well, I shouldn't use I here because I is used as a parameter up there. So I'm going to use another name here. I'll just use K, okay? So K is I to bar A bar minus 1, A subscript K. I can say, I can solve this problem. I know how to find out the summation of all the elements, starting with index I to index bar A bar minus 1. I know how to solve this problem. by expressing it as one single addition of myself, which is a bracket I, plus the summation, again, of k equals, this time I plus 1, the guy next to me, all the way to the end of the array of a bracket k. That's what I'm doing. I'm just reducing the problem in size by 1 and say, hey, somebody else has to solve that problem. Is that making any sense? Okay, so this can continue like this until I itself is bar a bar minus 1, then becomes a single element, then I can just say, okay, it's just me, I don't need the rest anymore. Okay, in other words, if I keep going like this, then the last one is the summation of k goes from bar a bar minus 1 to bar a bar minus 1 of a bracket k. But you know what? That is easy to resolve because it's just a subscript bar a bar minus 1. So there are no recursive steps anymore at the end. Okay? So why is this approach useful? Why do we want to express the solution to a larger problem as a simple thing in addition to a problem that is similar to the original problem? It's just one size smaller. Okay? Why is that important? Why is that a useful concept? It's kind of like, if you look at this, it's kind of like Russian dolls, right? You open it up, you take one out, and the next one is, hey, it's the same thing. You open that one up, and you have another one that is about the same thing. Yep.
It's basically, in a way, the top-down design that we were talking about a few weeks ago, like just breaking it up into a smaller part and then going from there. Like
Yep.
continuing.
It's a way of looking at things. Okay, it's a way of breaking down something. Yep, go ahead.
I was going to say it's easier to automate, and it makes
It's easy to automate. It's about the same as using a loop to do it. Okay, if you use a loop to do it, it's about the same. You can still kind of solve it. In fact, using a loop to solve this problem is more efficient. It takes less time, just a little bit less, but not a whole lot. Okay. The biggest advantage of doing things like this or looking at problems like this goes all the way back to something that you don't want me to mention again in this class. Pre and post conditions. Now, why do you think this goes all the way back to pre and post conditions? What is the one thing when we talk about pre and post conditions that I said, I'm not going to ask you any questions about this? There was only one thing that I promised that I would not ask questions about.
If you said that, we probably forgot it.
Okay, we have basically 3 different types of statements in this class in terms of controlling the flow of a program, not counting subroutines. We have assignment statements, right? So we have 2 types of assignment statements when it comes to pre and post conditions. We have ones that has a right-hand side that is reversible, and then we have the ones that are not reversible. And therefore, one would use a substitution operation, the other one would use a forget operation to go from the precondition to the post condition. Okay? We have conditional statements. Okay? We can have a conditional statement that looks like the original one, like this one, with only a then branch but no else branch. We can have one that has an else, then, and else branches. We can have ones that have multiple branches. But all of those are conditional statements. In other words, we are just talking about how do we split up the branches, but they all have to merge at the end and continue execution. What is the third kind of control structure that we talk about in this class? Loops. Okay? We have pre-checking loops where we perform the check first before we perform the body of the loop. And then we have post-checking loops where we perform the body of the loop first, and then we say, do we have to do it again? Right? The pre and post condition derivation of loops is the one thing that I said that I would not ask in any exam questions. Remember that? Because it depends on how well you can look, how well you can perceive the loop invariant condition in the loop. And that's a difficult thing to do. Remember all that stuff? No? All right.
Yeah, watching YouTube.
Okay, you have to watch it again. Okay, so that's what we were saying, because loops are harder to analyze, okay? Because it has to go back. The post condition of one statement becomes a part of the precondition of the same statement. That is what makes it tricky, okay? Now, if it is difficult for one single statement in the loop, what if you have multiple statements in the loop? That makes it even harder, right? Do you see any loops here? I don't.
Now we don't see anything.
Oh yeah, now we see other things too. Okay, but I don't see any loops here. I don't see any while do. I don't see any repeat until. I just see a conditional statement. So when you want to prove the correctness of this particular summation algorithm, it is different because you don't have loops anymore. We only have conditional statements, return statements, and that sort of thing. When you have problems expressed in this particular way, the proof of its correctness lends itself to what we call proof by induction. Okay? Does anyone know what is proof by induction in this class? Okay, very few, but if you are going to go through the entire computer science degree, or the transfer degree in computer science, that's the new name of the degree. Same thing, just different name. Everybody will have to go through cisp300, which is discrete structure. In that class, it will formally introduce how do you prove something mathematically. And proof by induction is one of those things. It's a very interesting proof technique. It is also very powerful. And using proof by induction, you can prove the correctness of an algorithm that is recursive easily. Okay? And that is also one reason why sometimes we want to express problems in a recursive way, is because it is easy in some cases to prove its correctness because there are no loops. Okay? Even though effectively it is doing what a loop does, it is actually easier to deal with in this case. All right. But getting back to the homework assignment, is that helping with your homework assignment? Because this is the only one missing piece from the homework assignment that we have not talked about, is how to pass an array by reference. So are we doing okay with this one? Okay, your homework assignment is a little bit longer, so you definitely want to start earlier this time. All right, so now we have about 15 minutes left for the exam questions. So we'll go ahead and take a look at those questions. I have not done any grading yet. I'm sorry about that, but I will do some. Over the break, it was just
too much turkey.
No, actually, my son picked up an interest in archery. And so he got a $25 set of bow, arrow, and stuff like that. $25. It's not bad. And then we went to the Discovery Park, to shoot some arrows. And obviously, I got really bored, just helping him pick up his arrows, because as a first-time, archer, all his arrows went past the bales of hay, onto the other side, and it was really hard to find because we have a lot of fallen leaves and it was on grass. So the arrows, have a really good way of hiding themselves, and we spent a lot of time looking for arrows. So after a while, I got bored and I got my own set. So now we can actually go there and actually shoot something. I can hit a milk jug, like a gallon size, from 20 yards, 1 out of 6 times or so. But I can tell you this, from my personal experience, that kind of accuracy is better than. Where's the exam? I just uploaded it. Oh, right there. That kind of accuracy is much better than what I have seen at a gun range already. All right, so this is the exam 2. Unfortunately, the first question does not have a problem as much as you wanted to have a particular problem.
It had a problem.
Okay, So this is a conditional statement.
You're gonna want to pretend to have a problem after you go through it.
All right. All right, so let's take a look at this one. I remember in the mock test, we also have a conditional statement. It's the same kind of question. I give you the post condition, and you have to reverse all the way back to the precondition, and then start from there to derive the post condition again. So it's the same nature in this case. Okay, so let's go ahead and take a look at this one. We may not be able to finish all the questions today, but at least we got through the homework assignment. Okay. So in this case, we have, let's start with the post condition here. The post condition is post 5 is x equals 5, and y equals 4, and k equals 2. Okay. So we want to reverse this all the way back to pre-1 and then go forward again. Going backwards, you don't have to show me the steps, but it might help you in the exam as you write it down. You go, oh, okay, okay, this seems to make sense, and you can make another step instead of doing everything in your mind. That can. That's a little bit more complex. Okay, for something like this, I would need to put it on a piece of paper. Okay, so post 5 is actually post 4 or post 2. Remember, that's because of the structure of a conditional statement. So that means post 4 can potentially be the same as post 5. Okay, so we'll say, okay, let's say post 4 is the same thing here. And there's also a chance that post 2 is also exactly the same thing. All right. Now, if post 4 is that, okay, if post 4 is the same as post 5, which means x equals 5, y equals 4, and k equals 2, is there a way for me to infer pre-4? In other words, knowing what post 4 is there a way to go back and say, well, if I know that x has a value of 5 after subtracting k from it and k is 2, can I infer the value of x before line 4?
Yes.
Okay, and that would be? 7. Yeah, exactly. X has to be 7. And k equals 2. But there's one more thing about pre-4 that I have to add here, because in case of pre-4, the condition of the conditional statement has to be false in order to get me to the else branch here. So that means it cannot be the case that x is less than y. Is that making any sense?
Yeah.
Okay. And I can apply the same kind of analysis to post 2. Go ahead.
Could I have said that x gets x plus k?
X
pre-4.
gets. You could, but that won't give you the same, the actual value.
It won't?
Well, are you talking about? Okay, are you talking about 5 plus k, or are you talking about x plus k? Because those are different.
They are?
Oh, they're way different. This is always false. There's no way x can be x plus k.
Well, you said you don't care how we arrive at the conclusion that x is equal to 7, right?
That is correct.
Okay.
Okay.
See what you're doing. You're golden.
But when you go forward, you better make sure that you don't write anything like that. Okay, so knowing this is post 2, what is pre-2?
X equals 3.
X equals 3, because after we add 2, it becomes 5. So before we add 2, it has to be 3. Y equals 4, k equals 2. And by the way, you may not be seeing this exact question because I have 4 variants of the same thing. So don't worry if you say, hey, that's not exactly how my question was phrased. Okay, but the condition of the conditional statement also has to be true in order for me to get to pre-2. Okay, so now let's see if we can do some simplifications here. Okay, is there any way I can simplify this statement? In other words, is anything here is it redundant? I don't have to say that. It's implied. Which part of this do you think is implied by the rest of the statement?
The very last part.
The very last part. Does it conflict with the rest of the statement?
No.
No. So that means the entire thing can be simplified to exactly that. Are we doing okay so far? Okay. What about this one here? Can we simplify this a little bit? Or is anything conflicting? No. X is less than y is not conflicting with the rest because x is 3, y is 4, 3 is less than 4 is true. So that means we can apply the same techniques to simplify it. Okay. Now, if you don't simplify, that's okay. Okay, that part does not bother me. But what is important is whatever pre-2 you have, whatever pre-4 you have to say pre-1 is a disjunction of those two. So pre-1 is a disjunction of pre-2 and pre-4. Now, we just say this here. And there's no need to simplify this either. Okay, if you want to, you can do it, but if you don't, I won't take any points off. Okay, so that really is pre-1. Okay, but once you look at the two conjunctions, the big conjunctions, on the two sides of the disjunction, you will say, but they are kind of common. I mean, there's a big chunk of it that seems to be common. So if anyone wants to do this, you can actually do a simplification, which is to take out the portion that is different and then use a conjunction to connect it to the rest. So that means exactly the same thing. It simply means that we know that k must have a value of 2, and y must have a value of 4 out of the original code. But isn't that kind of obvious out of this? Because the only variable that can possibly be changed in this entire algorithm is x. So whatever we know about y and k cannot change whether you go forward or backwards, because nobody's changing those two variables. So that part is pretty, kind of obvious. This part is obvious. This part is a little bit tricky because depending on which side you merge back onto pre-1, x can be 7 or it can be 3. Okay? And then you start with this as your precondition. You move forward using the same technique that we talked about in this class. All right, so knowing this, we'll go forward. We'll basically say, what is pre-2? Well, pre-2 is pre-1. Whatever is true before line 1 executes still has to be true, but the condition also has to be true too. So now it becomes x equals 7 or x equals 3 and k equals 2 and y equals 4, and on top of everything else, x is less than 4. Okay. Is there anything I can do about this?
Yes. X can equal 7.
X cannot equal to 7, okay? But if you don't do anything about it, you know what? That's okay, okay? Because if you just say, well, that's what pre-2 is, I'm just going to start, I would just derive post-2 from this pre-2, that's okay, okay? In this class, you don't need to do the simplifications, but you do have to apply the operations correctly, choose the right operation. So now we look at line 2, and then we say, all right, if that is the complexity of precondition of line 2, what do we do with post 2? Then we say on line 2, the right-hand side refers to the left-hand side, and it is reversible. Okay? Because if f of x is x plus k, then the inverse of that is just x minus k. Then you can say that you are going to use the substitution operation as a result, okay? So I need the explanation of why the substitution operation is selected instead of the forget operation.
You mentioned the word reversible. Can you just state that there is an inverse and then annotate that we're going to use substitution?
Yeah, you have to mention it somewhere.
Okay.
So that I know how you make that connection, that you have to use a substitution operation here. So now we can say post 2 is the result of using the substitution operation. On pre-2, we are substituting all occurrences of x with f prime applied to x. So this part is also needed because that's how you derive the post condition from a precondition when you use the substitution operation. The next step is just expanding what is pre-2. If you do not simplify pre-2, you have basically a longer one, which is okay. It's not a problem. And then the rest is just like this. And then f prime of x is x minus k. And then after this, it is really just a matter of mechanically replacing x with x minus k. So now you can say x minus k equals 7, or x minus k equals 3, oops, and k equals 2, and y equals 4. That's fine with me, okay? You don't even have to put in, oh, k equals 2, so I put 2 into here, and then resolve, and say k equals 9 or k equals 5. You don't even have to go that far. Just give me the mechanical result of the substitution operation. We call it good. Okay, and we can do the same thing with post 4. So pre 4 is pre 1, and the negation of the condition of the conditional statement. So it's basically the same thing. You don't have to do the simplification if you don't want to or don't know how to, because this class is not about Boolean algebra. So you basically just say, okay, pre 1 is x equals k, or x equals 3, and k equals 2, and y equals 4. And as long as you append this part here, you're good to go. Yep.
I thought we were just trying to find pre-1.
We're going back to pre-1, and then we go forward again.
And then you derive post 5 from that.
Yeah, because from here, then use pre-1, then you figure out to derive post 5. So you have to go forward again. So going forward again, so this is okay as a pre-4, okay? Because what I really am looking for is you're linking pre-4 to pre-1, and also the negation of the condition of the conditional statement. That tells me that you understand the structure of the conditional statement and how it impacts the condition of one of the branches, the precondition of the entire else branch in this case.
Instead of x less than y, I did not. I knew what I was doing. I just stated x is greater than y.
X is greater than or equal to y.
Okay, because I didn't negate x is less than y.
That's why it's important to put this one here. Is if you jump from not x is less than y to x is greater than y, then
the possibility of it being equal to here.
Right, but that's also why I cannot give you the partial credit, because it's not x is less than y is equivalent to x is greater than or equal to y. If you miss the equal to, then it's not exactly the same thing. But if you state this one first and then you do the simplification, I'll just say, well, you know what it is, you're just deriving it incorrectly, which is an optional step. So the rest is about the same as the other one. So once you have post 2 and post 4, then post 5 becomes the disjunction of those two. So you might end up with something that is exceedingly long if you don't do any simplifications within the steps. But as long as the steps themselves are correct, you still get full credit for it. Yep.